Alright folks, so this is going to be the last set of video notes for this class. I know that a lot of you are happy about that. So we're talking about arrays and how arrays are going to be used. So let's start at the ground level and see how the arrays work and how they're declared and how they're stored and all of that. So we have a number of options with the arrays. We have one-dimensional arrays, which is basically a series of memory locations that's one-dimensional that contains data of the same data type. And there's two-dimensional arrays or multi-dimensional arrays. That is one array, but it can have multiple rows, and we'll see that here in just a minute. And then there are parallel arrays that are effectively two array variables that are used at the same time, and we'll see that here in just a sec. So an array is it's a variable name or identifier, just like we've been using in the past, that stores data in memory, and the data is stored sequentially in memory, and the value of that array, every element in that array must be of the same data type. And it just as I just suggested, each piece of data is stored in an element, and then that element can be accessed by an index number and or a subscript, and we'll see how that works here in just a second. But it's important to note that every series of indices start with 0. Now your textbook kind of goes in a different direction to make it a little more simple, and suggests that it starts with 1. But let's stick with how the computer manages those arrays, and we'll remember that all the indices start with a value of 0. And just like every other variable that we've used to this point, it must be declared with a meaningful identifier before it can be used. And that meaningful identifier is going to be something other than a single character variable name. As I mentioned before, those values in the array are stored sequentially. And then there are some advantages to the arrays. It decreases the number of variable names that you have to manage through your program, and that certainly is beneficial when you start getting longer and longer programs. And it can make your code more efficient and decrease the access time when accessing that data. So as I mentioned, parallel arrays are effectively array variables that are accessed at the same time. So, and we'll see that here in just a sec. But basically, you can have one array of a string data type, and then another array as an integer data type. And as you're going through a for loop to enter data into one of those arrays, you can use the same for loop to enter data into the second or parallel array, and just makes your code a lot more effective. And again, I'll show you some code to show you how that works here in just a sec. And as I mentioned, the two-dimensional array is two columns or two values of the array, and I'll show you how that works. That should really be multi-dimensional array, and we'll because it can either be two-dimensional or three-dimensional or 12-dimensional. So one important note is that two-dimensional array requires a second index number, and we'll see that in just a sec. So one important note, and this is important as you if you come into a situation that you might need to use a two-dimensional array, for instance, your final project. The first number signifies rows, and the second number signifies columns. So you can put that in a nested for loop and have the outer loop control the rows, and the inner loop control the columns. So let's take a look real quick on how that works, and we'll see if we can clear that up a little bit. So this is another version of assignment 3 that created the multiplication table from 1 to 10 on both sides. So let's take a look at what's going on here. We declare two integers called row and column that we'll be using in our nested for loops here in just a sec. And then we create a two-dimensional array called multiplier, and this is going to be as an integer. So notice that this is 10 by 10, and think for a moment as an Excel spreadsheet where you have 10 rows and 10 columns, and the products of that multiplication table is going to be contained in that spreadsheet. That's exactly how this works. So the first function that we call is calculate table, and notice that we are sending the variables multiplier and row and column to the multiplier table. I'm sorry, the multiplier function. So when this lands down here, notice that I'm passing this multiplier array variable as a reference. And recall that since that's being sent as a reference, that's effectively creating a new identifier for the same memory locations. So when we alter those values in the memory locations, it's altering the same memory locations as what's being referenced in main. So I also pass row and column, and notice that I'm not passing those as reference because I don't really care what happens to those values. I'm going to be changing those inside the function anyway. So inside this function we have a nested for loop. Like I said, the first for loop controls the rows, and the inner for loop controls the columns. So notice what happens here. We're at row 0 or row 1, and then we go to column 0, and we set the multiplier array to, and row right now is 0 and column is 0, and we set that to the product of row plus 1 times column plus 1. Now notice what we're doing here. Since row and column are both 0, I have to increment both of those by 1 to give the proper product. So again, this is going to go into 0, 0 of that is the index for that element. And then it's going to end column, and it's going to row, and then it's going to increment that. And I've already gone through the function of a nested for loop, so you kind of see how that works. And all this function does is enter the data into that multi-dimensional array, that two-dimensional array. Now notice that there's no need for any line breaks or tabs or anything like that, because all we're doing is entering the data. So then once the calculate table is complete, we go back up here and go to the next line to call display table, and we go to, and again we're passing the multiplier and row and column. We pass multiplier as a reference, and now remember that we passed multiplier to calculate table function and altered its contents within this function. So when we pass multiplier to the display table, it's carrying all that data that we calculated in the calculate table function. So again, we go through this nested for loop, and we are outputting one line at a time. We do a write the contents of multiplier, row, and column, which right now is the first iteration is 0, 0. And of course that's going to be the product of 1 times 1, right? And then we're going to tab, and then it's going to do that 10 times. Going to come down here, print a new line, and then it's going to increment row by 1 and do the same thing. It's going to happen that going to go through that 10 times and display 10 rows of products to create our multiplication table. So let's take a look at what's going on in memory when we create a multi-dimensional array. So we've got, let me see if I can shorten this up a little bit for you. So we've got these are all memory locations. Now these darkened area are the memory locations. So these numbers over here to the side are the indices that we're talking about when I talk about row and column. So for the row, that's going to be these indices here, and then column is going to be these two indices. So notice that I've got row going up to 10 and column going up to 2. So now this is just a piece of a function that we're working with right now. So we declare student name and state. This is just an example. So we're declaring that as a string because the student name, of course, is going to be a string value, and then the state is also going to be a string value. Now notice that these two values have nothing at all to do with the length of the string. This is the row and this is the column. So we will have 10 rows of students, and each row will have 2 columns. So and then we also declare another variable array that is an integer that's going to be the student number. And then we declare 2 integers called row and column that will be used in our nested for loops. Now notice what happens with this nested for loop, and notice what I'm doing. So on the first pass, row equals 0 and column equals 0. So if column equals 0, which is effectively, that's going to be the first column, right? So if column equals 0, then write the student's name. So we're going to give the user an input command to put that student's name in the location of 0, 0. So name is going to be the first column. And then it's going to skip the else portion and go back up to column and increment column by 1. So column is now going to be 1. So if column equals 0 and it does not, so it's going to go to else. It's going to instruct the user to enter the student's state of residence. And of course this value is going to be 0 and 1. So the second column over here is going to be state. This is going to be name and this is going to be state. So it's going to be enter that state, and then once that finishes, now notice what happens. It exits this inner for loop, and it says it outputs to the user, enter the student number. Now notice that we have, this is the parallel array that we were talking about, or parallel arrays. So we have 2 arrays that are working, or that we are entering data into together. So we're putting data into the student name state variable and the stu_num variable. So at this point, now notice that this is still row 0. We're still on that first row to enter the data for the first student. So we have already entered the student's name and the student's state of residence, and now we're going to enter the student number because that's still 0. So once the user enters the student number, then it's going to go back. It's going to go to the end of that for loop, go back to the top, increment row by 1. Now we're on the second row. Now it's going to go back into the column for loop and enter the name and state, and then it's going to go. It's going to exit that for loop and have the user enter the student number. And now notice that value for row is still 1, so it's still going to be entering in that same row. So that's pretty important information, and potentially you could that might be helpful to you when you're working on your final project. I would recommend that you use something like that. I mean, there's, as I always say, there's always more than one way to skin a cat. So, but take a look at that, and now you can also use something similar to this when you are testing to see if a student lives in a particular state, for instance, and then increment a value, or do whatever you need to do. But keep that in mind, and hopefully that helps you wrap your brains around the arrays and how they work. Um, and I think that's all I got. So real quick, I just wanted to point this out. So as I mentioned, this is one array. This entire section, this is the array for student name state, and notice the indices here. This first element. Now each of these memory locations in this array, which is again the darkened area, those are elements. To address a specific element, you have to address it by an index or an index number. Now, with a multidimensional array, you're going to have two numbers that's going to create that index. So this memory location is going to be 0, 0, and then 0, 1. That's for the first row. Again, these are rows and these are columns. And then 1, 0, 2, 0, 3, 0. Again, rows and columns. So keep that in mind and kind of try and wrap your brain how that works with the multidimensional arrays, and hopefully that helps you out when you're working on your final project. Good luck, guys.